In this video, we're going to cover an advanced orthokeratology design concept that is creating an oval optic zone to treat corneal cylinder. Before getting into oval optic zones, I want to stress a few points here. One, you should have a number of wave orthokeratology cases already completed. You should have a complete understanding of that design process and also a complete understanding of how to troubleshoot an ortho-K fit. You should be very comfortable analyzing corneal topography and handling patient expectations. And I would like to stress that in most situations, an oval optic zone is really not necessary. But a skilled designer can tell whether the initial design calls for an oval optic zone or if a spherical zone will work just fine. And remember, more complicated is not always better. And in many cases, the more simple design simply works best. So with that disclaimer, I will say there is a time and a place for oval optic zones with Ortho-K. When to use one is entirely up to you. In this video, I'm going to show you the principles behind designing an oval optic zone and how we go about creating that design, as well as a couple key points to keep in mind regarding lens orientation. Now, the first step, as with any Ortho-K lens, is patient screening. Not only is the patient a good Ortho-K candidate, but do they require this oval optic zone, or will the standard spherical optic zone work just fine? Now remember, they're used to treat a greater amount of corneal cylinder. If the patient has a residual cyl, an oval optic zone will probably not be as beneficial. And remember, not all cyl is created equal. Limbal to limbal cyl is going to be much more challenging than centrally located cylinder. Also, keep in mind the amount of cylinder in relation to the spherical component of the RX. All else being equal, a spectacle correction of -350, -125, axis 180 will probably be more successful than a -125, a -25, -150 axis 180. And again, it will come down to experience and patient screening. And now we're going to go ahead and actually design a orthokeratology lens with an oval optic zone. So we're going to use this cornea as an example. And we'll note a few things here real quick. We have about a diopter and a half of cyl with the rule. Spectacle RX has -1¼ diopters cyl, axis 180. So that tells us that these line up fairly well. We should be fine here to create an oval optic zone. Now, with a scenario like this, I personally would probably design a spherical optic zone to begin with, and if there was still cylinder left over after the initial treatment, then I might add the oval optic zone based on that. But for this video explanation, I'm really going to show you just how to create the oval optic zone, and when you use it, when you don't use it, will come down to your personal experience. So this is a standard straightforward lens here, and if we think about it, we've got a power of +146 based on the topo demand of 557 here, and the RX of -350. So by having a power of we'll just call it 150 for even numbers. So we have a power of +150 on this lens, and that's designed to get this cornea to about plano, or maybe a little hyperopic, maybe +1/4, +1/2. What we want is to get an additional 125 cylinder of correction along the vertical meridian where the cylinder is. So all we need to do is think of this as a power cross. Along the horizontal portion of the cornea, we know that this power of +146 in the lens is going to treat this -350 cyl. That's along the horizontal. Along the vertical, we can expect, because the cornea has another diopter and 1/4 of cylinder, that cylinder won't be fully treated by having the power of +146. So what we're going to want here is an additional 1¼ diopters of power in that meridian. So we'll want to get the lens power up to about a +270 in the vertical meridian. So now we're ready to add the oval optic zone in. So what we're going to do is essentially go to one of the vertical meridians, and we're going to change our quadrant control setting to 50%. Now the OZ and the IC are set to the standard 6.2 and 6.8. What I want to do is move the OZ in, and I like to move it to 5.6, and what I'm doing, if you'll notice, the OZ lift change is still equal to 0. That refers to if I'm moving up or down here. So I just want to move into 5.6, keep the lift change at 0, and drop it there. And then I'm going to move the IC in as well to 6.2, and here it's more important to keep that lift change at 0. And just let it go. And now you'll see I have more of an oval look to the top of the lens, and I'm going to want to do the same thing inferiorly. Because I'm in freeform, if I were doing this in GSIM, as you know, I would only have to do this once. So here I'm going to move this over from 6.2 to 5.6, keeping my lift change at 0, and move the IC from 6.8 to 6.2. And there you have it. Now we have an oval optic zone. And you'll note the floor seam pattern is more of an oval shape. And if you look at the back curvature view, it also has an oval shape, and you'll see a little toricity in the treatment area. Okay, so now we're going to actually adjust the topo demand and the vertical meridians to take care of the excess cylinder that's needed. So basically, we'll think of this again real simplistic. The spherical component of the RX is a minus 350. The initial lens was designed with a power of plus 146. So this is essentially assuming that the cornea is spherical. Now we know in this case it's not. We have another diopter and a quarter of treatment. So if a plus 146 power of this lens was designed to treat a minus 350, we need to treat an additional 125. We essentially want to get this power up to about a plus 270, 271 if we're going to be exact about it. And that's really just adding the initial power of the lens to the additional treatment that we want in the vertical meridian only. So we'll leave our quadrant control setting at 50%, go to a vertical meridian, and just by dragging the OZ and the IC over and leaving the OZ lift change at 0, you'll notice that we ended up in this case pretty close, 273. So I can leave that just where it is. If we needed to adjust that, we would simply click up or down under the red dot until we reached our appropriate power. Since we were aiming for about a 270, I'll leave it right there. And since we're in freeform, we need to do the same thing inferiorly. And you'll notice in this case, inferiorly, we did not end up perfectly at 270 again. We're at 273, so our goal is to get this power down to 273. So we need to essentially steepen the central curvature of the lens in this meridian. So I'll click down under the red dot until we get to just about a 273, so 271. So that's going to be good. And now our power is adjusted. You'll notice we have across the horizontal a 146, 147, vertically 273, 271. We have our oval optic zone. To recap the steps to create an Ortho-K oval optic zone, it's really, remember, we're just starting with a standard Ortho-K lens, and then in 50% mode we'll move the optic zone and the intermediate curve in to create the oval. I like to move it into about 5.6 and 6.2 in most cases. Then simply calculate the difference of the topo demand needed, and in 50% mode adjust the power or base curve of the lens along that cylinder to the desired amount. That's really all there is to it. It's very simple, very straightforward. After you do a couple, it really starts to make sense. It's not that much more difficult to design the lens than any other wave contact lens. It's really just a matter of knowing when to use it and how to use it. And one closing note I want to make on that is, remember with an Ortho-K lens, it only fits the cornea out in the periphery. This little area out here is the only part that's actually lining on the cornea. So when we create the oval, we get a little more alignment out in the periphery, which helps centration, and also by closing in the OZ, we get a little more compact treatment zone, which should help out with the cylinder as well. So between those two factors, we usually get fairly good alignment. Now with that said, you should be able to look at a cornea and note whether or not we have a really good chance of the lens aligning here. Now this cornea looks a little bit steeper inferiorly, so we get a little more of this light green coming down through here, where up here it's not so much, maybe a little band, but we really have the heavier green coming in a little faster. Therefore, the cornea is different out in the periphery. The lens probably will align just as we want, and this Ortho-K lens will probably treat most of that still as we are anticipating. And that's really it. Then just clean up the lens, adjust your center thickness and edge thickness if you haven't already, to how you prefer to design your lenses, and that's it. Save and order.